Now we will be looking at problem solvings or looking at applications of using constraints in real world problems. So using inequalities. Okay, so Ben is buying snacks for his friends. That's not important. He can spend up to $12. The choices are apples for 60 cents and muffins for $1.20. He needs to determine how much of each item to buy. So here we have the inequality already given to you. We need to define our variables. So here, usually, x would always be the first variable presented in the problem. So apples will be x, and then muffins would be y. And if you look at your equation, the 60, the coefficient for the x value is reference to 60 cents, which is reference to the apples. So x would be apples, and y would be muffins. What kind of muffin, you might ask? I don't know, all brand maybe. Healthy option. Okay, graph your inequality, label your graph. All right, now here, this is the tricky part. Are we going to have negative apples or negative muffins? The answer is no, so we will only be looking at the first quadrant. Here, we will only be looking at positive values, and so that leads to extra restrictions that you have to write down, meaning that x is strictly greater than 0 and the same for y, because we're dealing with strictly positive values. So to label that, this is my y axis, but y represents muffins, so you will write muffins. And then here, this is my x-axis, so you will write apples. So now you have to graph this function. So I would recommend you using the x-intercepts. So let's find our intercepts before moving further. So here, if what is the y-intercept if x is 0? So let's do that. If x is 0, 12 tenths times what gives me 12? That's 10. So that means that if x is 0, y would be 10. So 10 squared, 10 units, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here we go. That point, you can label it if you wish. 0, 10. Let's do the same for the x value. What is the x-intercept if y is found to be 0? Okay, so let's do that. If y is 0, 6 tenths times what gives me 12? That's 20. Now, if you notice, there's not 20 squares here, so we'll have to change our scale, meaning that each unit would represent 2. That would give me the 20, because here it'll give me 20 for my x-intercepts, because we want to get to 20. So 2, 4, 6, 8, 10. And you don't have to write every one. Here we know that 5 is 10, so 5 more would be the 20 that I'm looking for. So here, this would be my other intercept, and here it would be a dotted or solid line. Solid line, because I have the points found are on the line would be solution. So how much items would he need to buy? Identify two coordinates that satisfy the inequality and prove why it satisfies the inequality. So 2 points. Any points found in this region here, this is the feasible would be solution. But let's just go to spending all this money, because Ben looks like a guy who's going to buy snacks to his friends, so he wants to get as much snacks as he can. And he wants it, let's say he wants a variety. So let's say this point here. So that point there would be 8x value, so 8 apples, right? And that would be, let's see, 1, 2, 3, 4, 5, 6. 6 muffin, good variety there, good mix. And maybe let's go even and even, let's go even more even split. Let's maybe go over this way here. Let's see what would generate. This would be six, 6 apples and let's see, 7 muffins. So two possible solutions to the question. So you could say um, 8 apples and 6 muffins would be one, or you could say 6 apples and 7 muffins. So are these the only two answers? No. How many answers are there? Well, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then all the other points that are found here. So you would have all these points here. You can't have half a muffin or half a apple. So any points that are found here, you can count them all. And that's how you graph using inequalities to solve a real world problem.